right, this is the notes for section 5.4, and we're going to be looking at multiple types of factoring. We did factoring in chapter 4, which we're going to review first, but then we need to talk about how to factor when we get some bigger polynomials like x cubed, x to the 4th, things like that. And so we're going to start just making sure we go back to chapter 4 and we remember those. If we look at the first one, there are only 2 terms and they have nothing in common, okay? So we look at the 9 and the 1 and we say, oh, those are perfect squares. So we said in order to get 9x squared, you could take 3x times 3x. And to get negative 1, you could take 1 times negative 1. So my 2 factors would be 3x plus 1 and 3x minus 1. This we called a difference, maybe, of squares. Okay, where we looked at the 2 numbers and said we're subtracting 2 perfect squares. So this was the first type. The second type we looked at only had a single x squared. And so what we did is we looked and said, well, x squared then is x times x. And 16 is 4 times 4 in this case, because 4 plus 4 adds to 8. And so we said, okay, this is x plus 4 times x plus 4. Make sure that looks like a 4. Which, we don't write it as x plus 4 and x plus 4. Rewrite it as x plus 4 squared. Okay, and that was our basic type of factoring. Let's make that look like a parentheses. The third type, we said, well, we have only two things, only 2 terms. And if I look at them, I can see some things in common. First and foremost, they both share an x. The second thing, if you look at the 8 and the 20, a 4 is the biggest number that can go into both of them. So if I do 8 divided by 4, I get 2. I had 2 x's. When I take 1 out, I get an additional x. Plus, 20 divided by 4 is 5. I had an x, but I took it out, so I closed my parentheses. And we're done here because we ended with a linear factor, something that looks like mx plus b. This was called pulling out the greatest common factor, okay? The GCF, the greatest common factor, okay? The last type, we had a number in front of the x squared, and when we did that, we used the snip method, okay? So I'm going to make my table, and we did in the first column a times c, so 2 times negative 20 is negative 40. We want it to add to a negative 3. Well, 40, I think the one we're looking at is 8 and 5. The question is which one has to be negative in order to get a negative 3, and that's the 8. So we took the negative 8 and the positive 5, and we divided it by the leading coefficient, or the value of a. And we reduced our fractions to get negative 4 over 1, and we put an x on the bottom. The 5 over 2 didn't reduce, so we just put an x on the bottom. So our 2 factors were x minus 4 and 2x plus 5. Okay, and we're going to be using snip method again at some point in time, but I wanted to make sure that we reviewed one of each of those as we went through. Okay, now I want to start the second idea, which is called factor by grouping. Basically, we're going to group these together, okay? Now, you'll notice there are 4 terms with the ones in the middle column, okay? So the way we do it is we're going to group the first 2 together and then the second 2 together. And what we're going to do is look for the greatest common factor. So what do these first 2 terms share? Well, they have x's. They at least have x squared. So on the first part, I'm going to take out an x squared, and if I take out 2 x's, I have 1 x remaining, minus, if I take out an x squared, I only have the 3 remaining. I don't know why that won't curve. There we go. Now, on the second one, I got to look at the same thing. What do they have in common? My hint to you is we're going to try and use this negative 16. Can you divide 48 by negative 16? And the answer is yes. So I'm going to pull out a negative 16. And what's going to happen then is I'm going to get an x, and 48 divided by negative 16 is negative 3. And I'm going to change my color here a minute because I want to point something out. Look at, they both of these share a common factor of an x minus 3. And because they share it, like this first group shared an x squared, I'm going to pull out this x minus 3 in front. Okay? They both shared this x squared up here, so I basically removed it from each piece. And I'm going to do the same thing. If I remove this x minus 3 from the first piece, I have left x squared. If I remove the x minus 3 from the second group, I have left a negative 16. Now, the last thing we're going to ask ourselves is, can you factor this x squared minus 16? And the answer is yes. X squared is x and x. Negative 16 is 4 and negative 4. So I'm actually going to get an answer, and I'm going to write it above because I'm running out of space. But I get that x minus 3 that the two factors shared. And then I have an x minus 4 and an x plus 4. So here's my final answer. And the reason I have 3 factors, if you look at it, this is a single x and a single x and a single x. So 3 x's makes an x cubed. And we're going to kind of look at them that way. Okay? Now let's try this again. I'm going to take x cubed minus or plus 7x squared and group that. And then I'm going to take a negative 9x minus 63 and group that. Okay? In the first chunk, you'll notice they both share x squared. So I'm going to take x squared out, and I have an x plus 7 remaining. Again, if possible, I'm going to try and take that negative 9. So take negative 63 and divide it by negative 9. If you get a whole number, then we're going to use the negative 9. You end up getting x plus 7 again. That always has to happen, where you get the same factor in each of them. Because they share an x plus 7 factor, I'm going to pull that out in front. So x plus 7 gets taken out of each of them. If you take it out of the first one, what's left is an x squared. If you take it out of the second one, what's left is a minus 9. Now, this x squared minus 9 can be factored again, because x squared is x and x. Negative 9 is 3 and negative 3. So I get the x plus 7 that they shared. And then I get an x plus 3 and an x minus 3. My pen doesn't like parentheses. So here is my final answer going through. Okay? We're going to try one more. If you look at the last one, and actually let me change my color because they're kind of running together. I'm going to group the first two, and then I'm going to group the second two. Okay? In the first two, not only do they share an x squared, but they're both divisible by 17. So I'm going to take out a 17x squared this time. What I have left is an x, and 34 divided by 17 is 2. I'm again going to try that negative 9. Negative 18 divided by negative 9 is positive 2, which is good, because if I take out a negative 9, I get x plus 2 remaining. Since they both share an x plus 2, I'm going to pull that out in the front. And what I have left then, if I take it out of the first one, I have a 17x squared remaining. If I take it out of the second one, I have a minus 9. Let's see if we can make this pen work. X squared minus 9. And this can't be factored because 17 is not a perfect square. 9 is, but 17 isn't, so we're done here. Sometimes that'll work out where you'll factor more, sometimes you won't. I still want to look at degree though. There's an x squared in this one and a single x here. 2 plus 1 makes 3, so I can end with the x cubed that I originally started with. Okay? So that's what we're working with so far. The first type is called grouping. It's the second type that tends to be a little bit more difficult. I am going to give you these patterns on your test and on your quiz. So please be aware of that, okay? And we're looking for things that have two terms, and both of those two terms are what we call perfect cubes. And I want to talk about the cubes. We did perfect squares like 1, 4, 9, 16, 25. I'm going to look for cubes as well. So I'm going to say 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and you could keep going. I don't know how much higher we'll get, but you could keep going, okay? And so we want to use these numbers this time in a different pattern. The way the pattern goes is if I have two things that are cubed, I'm going to factor it like this. Take the first number plus the second one in the first group, and then I'm going to get a squared minus ab plus b squared. Okay, now this is in your book, and I'm going to show you how to use this. And not only am I going to show you how to use this, I'm also going to give you this pattern. Okay, if I subtract 2 cubes, in my first grouping I'm going to have a minus b, and then I'm going to have a squared plus ab plus b squared. Okay, now again, I'm giving you these patterns. So circle, star, and whatever, but this will be given on the quiz and the test. Okay, it's not worth memorizing, but you have to know how to use it. If you get really good at using it, you might not need me to give it to you because, again, you'll understand the pattern. Okay, so here's how we do this. What we're going to do is we're going to cube root each of the items and figure out what numbers to use. Okay? So if I cube root an x cubed, the cubed and the cube root go away. So my first thing I'm going to use is an x. If I cube root 64, what you end up finding is that's 4. Okay? And the cube root button is in your math section of your calculator. So you go to math. Actually, hold on, I can show you. If I look at this, let me turn mine on. If you go to your math section, see the fourth one down says this 3 with a root. If I go down to number 4, and I take the cube root of 64, close your parentheses, you'll see I end up getting 4. So 4 is the number I want to work with. Okay, so here's how it works. These are the two things I'm going to do first. Because it's a plus, I'm going to use the first pattern. So I'm going to add the x and the 4 together. That's my first part. Then what I'm going to do is I'm going to take x and square it. So x squared minus, because my pattern says a minus, now it says to multiply the two together. So x times 4 is 4x plus, and then it says take the second thing and square it. So 4 squared ends up being 16, and guess what? You will be done all the time. There is never additional steps when you're using this pattern. So you're done factoring. Okay? Let's try this again. Let's do a second one. If I cube root the first thing, I have to do this separately. I have to take the cube root of 8. So if I go to my calculator, I can go back to math, and I go down to the cube root of 8, and then close my parentheses, press enter. I get 2. Okay, so the cube root of 8 is 2, and the cube root of x cubed is an x. Now the minus doesn't matter. I'm going to cube root 125 also. You can go in your calculator and you can find it's 5. Because I have a minus, I'm going to use the second function, or the second pattern, to make this work. So here's how it goes. I take my numbers and I subtract them. So 2x minus 5. Okay? What happens is I square the first one. Well, if I square 2, I get 4. If I square x, I get x squared. And then it says plus, according to my pattern, and then it says multiply the two together. So 2x times 5 is 10x The pattern again says plus, and then it says square the second thing. So 5 squared is 25. Close my parentheses and you're done. Okay? I like this because if you can figure out what numbers to work with, you plug them in and you're done. So I tend to like it, but all right, let's keep going. Take a look. The problem with the third one is it's not an z cubed. That's our problem. So what we need to look for first is what can we pull out. If I look at this first, what I can do is I say, well, I can pull a 4 out. No. I can pull a 2 out and a z squared. So if I pull a 2 and a z squared out, here's what I get. 8z cubed minus 125. And that's important because 8 and 125 we just did. If you look at this, this is exactly the same thing as above, only with z's instead of x's. So here's what happens. I'm going to have a 2z squared in front, and then I'm going to follow the same pattern I did above. 2z minus 5 times 4z squared plus 10z plus 25. Make sure my pen's actually working. Okay? And the only thing that's different about this is there's something in front. Now I did the same example because I wanted you to be able to see that when you pull something out, you should get a cube. But this is the general idea going through for this pattern of cubes. Okay? Now, so we've done 2 new types, grouping, and the thing to keep in mind is there are 4, sorry, not very happy with my pen today. There are 4 terms. Okay, there are 4 terms going through. And if you look, 1, 2, 3, 4. In the factoring, there are 2 terms, and they are cubes. So keep that in mind, okay? Now, let's go to the back side and let's look at putting all of this together with what we did in chapter 4. Okay. What we are going to do is we are going to work on solving these, and whenever we went to solve, the biggest thing was that you had to put it equal to 0. Okay? In order to do that, I'm going to move the 18x cubed over. So I'm going to subtract 18x cubed on both sides. So I end up getting 3x to the 5th minus 18x cubed plus 15x. Set it equal to 0. Okay, now we want to look for what they have in common. Okay, so if I look at what they have in common, I can see I could take out a 3 and I could take out a single x. So if I take out a 3 and an x, 3 divided by 3 is 1, and I have 4 x's remaining. 18 divided by 3 is negative 6, and I have 2 x's remaining. Make that a 6. And 15 divided by 3 is 5, and I don't have any x's remaining. Now, this gets back. Now, I know it says x to the 4th, but it gets back to the same idea that we did with basic factoring. X to the 4th, if I split this evenly, I could get an x squared and an x squared. If I look at 5, 5 is 1 times 5. The problem is, to get a negative 6, both of these have to be negative. So what I'm going to do is I'm going to look at the fact that I have this 3x out in front, and then I have an x squared minus 5 and an x squared minus 1. Now, like we did in previous chapters, all we're going to do is to try and solve each of them equal to 0 and find out what they equal. So when I start with my first one, I say 3x equals 0. I divide it by 3, so x equals 0. There's my first one. That's supposed to be a 0. Okay. Second one, I say x squared minus 5 equals 0. All right, so I'm going to add 5 to both sides. X squared equals 5. When I square root it, coming back to chapter number 4, we always put a plus and minus. And you can't break down the square root of 5, so you leave it as plus or minus the square root of 5. My last one, I'm going to do the same thing. X squared minus 1 equals 0. I'm going to add 1 to both sides. X squared equals 1. Square root both sides, and when I square root, I get a plus or a minus, and the square root of 1 is just 1. Okay, so let me go back to my original polynomial, and I'm going to change the color a second so that we can point a few things out. Take a look. My highest exponent is a 5. What that means is I should have 5 zeros. Okay? Do I? Well, I have one where I said x equals 0. I have a positive square root of 5, and I had a negative square root of 5. And then from this one, I had a positive 1 and a negative 1. As long as I end with 5 zeros, then I'm good because my degree was 5 to begin with. I found all 5 zeros, so my answer is done. There you go. Okay, let's try another one. If you look, we're going to do the same type of thing. Can I take anything out of all 3? Absolutely. I can immediately see I can take a 4 and at least one x because I've got a single x here at the end. Well, if I take out a 4 and an x, I have x to the 4th left in the first one, minus 10x squared, plus I've got a 9 at the end. Okay, and I'm going to go through exactly the same way I did before. X to the 4th I can break apart as x squared and x squared. 9 is 1 times 9, but they both have to be negative. So I've got this 4x, and then I've got an x squared minus 1, and I've got an x squared minus 9. Now, I'm going to take it one step further than what we did before. If I look at these x squareds, this is a difference of squares, and so is the third factor. X squared is x and x. Negative 1 is 1 and negative 1. So that tells me this 4x is in front. And if I factor this first one, I have an x plus 1, and I have an x minus 1. Okay? Same thing with the 9. X squared is x and x. Negative 9 is 3 and negative 3. So I can write this as x plus 3 and x minus 3. Now let's see about getting my zeros. Okay? If I write this first one, it's 4x equals 0, like we did above, in this case, x equals 0. If I do the second one, we know that x plus 1 equals 0, and we know it's the opposite, so x equals negative 1. If I do the third one, x minus 1 equals 0, and again, it's the opposite, so it's x equals a positive 1. Fourth one, x plus 3 equals 0. Therefore, it's the opposite, x equals negative 3. And last but not least, x minus 3 equals 0. So x has to equal the positive 3. Now, here are all my zeros. If I count them, I have 1, 2, 3, 4, 5. And I should have 5 zeros because the degree was 5 to begin with. Because I have all 5 zeros, I'm done. Okay? Now I'm going to leave this last one because it's already kind of a lengthy video. This is an on your own question. We would like you to try this one before you get to class because then I can help you at least with some of the factoring. It's the same idea as the ones above. Find whatever factors you can. If you can't seem to factor this anymore or you're just not sure, then set them equal to 0 like we did above and show us just how you solved. That works too. Okay? So that's the end of section 5.4. Thanks for watching.